Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are starting Chapter 8, all about circles. So today we are looking at 8.1, constructing inscribed shapes. What are you learning? Well, by the end of this lesson, you will be able to construct regular polygons inscribed in a circle. Why? Well, these constructions will create the relationship between the segments and the angles in a circle. How will you know it? Well, you'll know you've mastered it when you can correctly construct a regular polygon inside of a circle.
Very exciting. So if you don't have this out yet, please make sure you have your compass and straight edge out. And I would like at least one highlighter out. All right, so we're going to be constructing 3 different shapes today: equilateral triangle, regular hexagon, and a square, all inscribed in a circle. For a shape to be inscribed, it's going to be completely inside the circle, and to be more specifically inscribed over just inside, the vertices of the shape must be on the circle. So the 3 polygons that we're going to be constructing will all be inside with the points, vertices of those shapes on the circles. So the first step that we are going to be doing for constructing an equilateral triangle is using your compass. You're going to draw a circle with the center as A. So you're going to draw a circle named A. Use your straight edge to then draw the diameter to circle A, and we're going to name it BC. So if you're using the guided notes provided by Mrs. Netz or myself, you already have this here. We would like you to trace it with your compass and straight edge. If you're doing this on your own sheet of paper, then you're just working along with me. So if you're tracing, this is kind of what I'm talking about. You're going to take your compass and put it on A, open it to C, and you're going to make a new circle, which should be perfectly right on top of the circle given to you. And then with your straight edge, you're going to trace right over the diameter of BC. When you make your own, this circle can be any size, and the diameter can be going at any slope. I chose to do diagonal. I totally meant to say horizontal, not diagonal. So you can draw the horizontal going any direction. You can draw the diameter going any direction you want. I chose horizontal for BC. All right, so our second step. So moving on to the next box, you can see circle A is still here, but now we've added a second circle. Without adjusting your compass, you're going to place the compass on C and draw a circle congruent to circle A. That is a really important step. If you do not draw congruent circles, this does not work. So please highlight that in your steps, that the circles must be congruent. So you could also do this step at B. I just chose to go to the right and draw it at C. So with your compass, go ahead and draw a circle at C. So here's our first one, here's our second one. I know they are congruent because my compass size has not changed, which represents the radius. And circles are measured by their diameter size or radius size. And the third and final step, you have your 2 congruent circles. Circle A is congruent to circle C because they have congruent radii. You're going to look at where the circles are intersecting. One of the places is right here. The other place is right here. We're going to name those D and E points. With your straight edge, you're going to connect B to D to E, and that right there, everybody, is an equilateral triangle.
Inscribed in
Circle A.
Circle A.
There you go. Now, you guys, if you're using your guided notes, you have a place on page...
It is on page
17, I believe. Yeah.
Yes.
Page 17. If you're doing your own notes, just somewhere in your own space, go ahead and construct an equilateral triangle inscribed in a circle. All right, so now we're going to construct a regular hexagon inscribed in a circle. So a regular hexagon, you're basically just doubling the number of points. So this construction is going to seem very similar to what you just did, because you're basically just doing what we did with an equilateral triangle another time, twice. I kind of changed the order. Rather than starting with the circle with a diameter, I'm starting with the diameter slash radius. So the first step is we're going to draw a long segment, and I'm going to name one end of it F. This is going to become our radius slash diameter of my new circles. Our second step, you're going to place the point of your compass on one endpoint, which I've named F, and you're going to draw a circle. So again, the line can be drawn however you want. I chose horizontal. And this circle can be done any size you want. Just bear in mind that you are going to be doing 3 circles if you've read ahead in the steps. So you need enough space in where you're doing this to fit 3 circles. So your first circle is just any size.
So you don't want to go too crazy stretching your compass out, because then you're going to need a really big piece of paper.
And you don't want to go too small because you're inscribing a hexagon. So if you go too small, it's going to be difficult to see that hexagon or to work inside the circle.
I would say a good spread on your compass, if you're ever trying to do this and you're trying to kind of figure out, what do I do here? How big should I go? I would say about an inch from the point of your compass to the pencil.
Yeah, I'd say the same. All right, so our third step, without adjusting your compass, you're going to slide over to where the segment and line intersect, and you're going to draw a congruent circle. So again, I would highlight that. This only works if you keep your circles congruent. So from F, here's circle F. You're going to slide to the right to where your circle F crosses that line, which is right here. And you're going to draw the same circle. So you end up having 2 circles at that step. And moving on to step 4, if you read it without adjusting your compass, you're going to repeat step 3. So you were here to begin with in step 2. You drew circle F. You slid to where circle F intersected your line to draw your second circle. And now you're just going to slide where your second circle intersects the line to right here and draw your third circle. If you do this correctly, the outer circles should be touching at the center of the middle circle. If they are overlapping or there is a gap, your compass changed at some point, meaning the circles are no longer congruent, so you're slightly off. So it should look just like mine. The last thing you're going to do is you're going to look at the middle circle only. I'm just going to highlight it really quickly right here. You're just looking at this circle. Hard to do. And you're looking at where is their points on the circle. So F is on the circle. If you look right here, well, my left circle and my middle circle are intersecting, creating a point, so we're going to name that A. My middle circle and right circle intersect right here. I'm going to name it B. The center of the right circle is on my middle circle. I'm naming that C. Then again, down here at the bottom are where the 3 circles are intersecting, so D and E, and then point F again was where we started. With your straight edge, you're going to go ahead and connect them, and you end up with a regular hexagon inscribed in the middle circle.
Very cool.
And now it's your turn, so go ahead and construct an inscribed regular hexagon. Okay, if you need more time, pause the video. We're going to move on to constructing a square inscribed in a circle. So the construction for inscribing a square uses some properties that you learned in Unit 3. For constructing a square, the diagonals of a square must be perpendicular, they must be congruent, and they must bisect each other. So if I were to construct a perpendicular bisector of a diameter and draw it so that it intersects my circle, they would be perpendicular and bisecting because we're constructing a perpendicular bisector, and both lines would be diameters in a circle. Well, all diameters in one circle would be the same length, making them congruent. So what you're going to be constructing, these steps, you're actually going to construct the diagonals of your square. So first step, draw a circle with your compass. We're going to name the center E. And then with your straight edge, you're going to draw your diameter. I'm going to name it AC. Again, I chose to go horizontal for my diameter. So we're going to trace the circle that's on our notes. And then with our straight edge, we're going to darken that diameter. In our second step, you're going to do the construction that you learned back in chapter 4. You're going to simply construct a perpendicular bisector to the diameter AC. So you open your compass over half the distance from A or C, depending on which side you want to start on, and you're going to draw 2 arcs that are congruent. So one from C and one from A. go. And then with your straight edge, you're going to draw your perpendicular bisector. Now, one common mistake I notice students making when I grade these. Students are used to just going to the intersections and drawing a line. And what I see a lot of times is they use these 2 points right here and here as their third and fourth points for their square, and they connect them to C and A. That would form a rhombus, not a square. So please make sure when you draw this line, you're actually intersecting the original circle.
And the rhombus would not be inscribed because the vertices would not be on the edges of the circle.
And then last step, as was the same with all of these, the last step is just look at the circle and look at for points. Well, we're drawing a square, so we need 4 points. We have A, B, C, and D. So with your straight edge, you're going to go ahead and connect A to B to C to D and back to A. And that is the end. You're going to try it now. So pause the video if you need to, or listen to us talk. I don't know. So hopefully you guys feel confident with constructing an inscribed polygon, which I spelled wrong right there, so I'll go ahead and cover up the wrong letter. Your next page of notes, page 20, if you're using the guided notes with us, is to construct a regular polygon inscribed in a circle other than the one we did in our notes. So you may need to Google this on how to construct something other than an equilateral triangle, square, or a regular hexagon.
Or maybe if you don't want to Google it, just kind of think about how we did the square, think about how we did the hexagon, and think about some other shapes that maybe you could use using similar techniques.
If you have questions at any time, email us, text us, whatever you need.
Hey, Mrs. Michael.
Hey, what, Mrs. Nats?
What did the farmer use to make his crop circles?
I don't know, what?
His protractor.
Ah, I love it. That's awesome. All right, we're very excited, so we will see you again in 8.2.